I'd like to open up or have any questions, please.
All right, thank you guys. At this time, I would like to read some of the questions that we've received. We did receive a question from Stephen, and he's asking that you define water hammer again.
Okay. Good question. Water hammer is caused by several different conditions. Water hammer generally is when the steam and water meet in either the steam line or the condensate return line. Steam is coming in at a very high temperature. It hits the cooler water. It gives up its BTUs and collapses. So when you hear water hammer, what you're hearing is exactly what it says. It sounds like someone is taking a hammer, pinging it on the side of a piece of pipe, and basically it is not the water or the condensate in the line boiling. It is actually the steam collapsing. It's an implosion of the gas. So it's a very dangerous condition. It does it at a very high speed, ultrasonically basically, supersonically I mean, and you will find that some of the indications would be damage to your pipe, damage to your heat exchangers and your process equipment.
Okay, thank you. We also received another question in from Mark, and he has a half-inch steam line with a number 150 pressure on a chart recorder. Currently, when the steam trap discharges, a spike occurs on the chart. What type of steam trap should he use?
Well, if it discharges and it's spiking and it's on a main header, it sounds as if that might be a thermodynamic style steam trap. A TD or thermodynamic style trap discharges at a in a cycling. It builds up, subcools the condensate around 5 degrees. The disc lifts, and the pressure of the system will push the condensate through the steam trap. If he doesn't want to see that spike, you would probably want to move more to a continuous action style trap rather than a blast discharge. So you may want to be looking at a floating thermostatic style trap, which will allow you a continuous discharge through there, and he won't spike on his chart.
Okay, great. We received another question in from Joe. Is one steam trap technology better than another?
That's a good question. I don't believe one technology is better than another in steam trapping, but you will find that the condition of your system could make one of those better than another. So you have to analyze your steam system, you have to analyze your process, you have to bring those to someone like myself for industrial controls. For example, we would say in a process system that a floating thermostatic style trap would be the best way to go. No one trap can handle every condition that is out there in a steam system.
Okay, great. Another question we received is from Bill. He's asking, what do I need to do to return the condensate coming off my steam lines back to my boiler?
Well, coming off your steam lines, depending upon what you're trapping, if you're talking about a main header, you need to trap your main header every 100, 150 feet, but you need to put a steam trap on that system. You may have to pump it back if your pressures in your headers or on your process is lower than the back pressure in your system, but you can either return it by using the pressure in your system, or you can take it to a flash tank and pump it back. You would then receive that condensate back in your boiler house at a deaerator or a condensate return tank of some sort and then supply that back into the boiler.
Okay. Another question we received is from Tim, and he's asking, can you give an example of an acceptable differential in temperature versus an unacceptable differential for steam trap maintenance and testing?
That's a good question, because in your steam trap system, if you were discharging off a main header, let's say 150 psi header, what you will find is your temperature on your inlet to the steam trap will be at saturated steam temperature, and you can find that on your steam table, on the steam curve. But your discharge temperature very likely could be very close, because you have not yet lost the BTUs out of that condensate. Your condensate is still under pressure. So depending upon what you're looking at, an unacceptable would be, in that situation, is that you had saturated steam temperature on the inlet or close to it, and on the outlet you would have a huge drop-off in temperature. That may indicate that you have a plugged or clogged steam trap. In most cases, you would find that you want to use the other two styles of testing as well to ensure that not just temperature is the all-knowing indicator. You need to check to see if that trap is blowing by ultrasonically. You also may want to visually inspect it by opening a downstream test tee or a downstream valve to inspect it visually to see if you have live steam, if you have no steam or no condensate, and no flash coming through. So the temperature depends on the style of steam trap you're working with, and you need to obviously inspect it with the other two styles we've discussed of trap testing.
Okay, thank you. One more question we received in is from Rob. Are there ways to remotely monitor steam traps to determine if they have failed rather than going into the field?
Yes, there's several different manufacturers and devices out there. There's a couple of them you work with that will actually monitor your temperature downstream and a wireless technology. You can do it by temperature. There are also ultrasonic wireless devices where you are listening to the signature of the trap for its operation. In a mechanical trap, you can hear different things than from a thermodynamic. But yes, you can monitor it wirelessly. You can monitor it with wires. At Industrial Controls, we supply a wireless system that's supplied by Cypress, and we can actually monitor your entire steam trapping system wirelessly, feed it back to your PLC, and give an indication as to what condition the trap is in. Blowing by, plugged, it's done by temperature and by ultrasonics.
Okay. Another question we received is from Ariel. What is the best recommendation for a flash tank?
Best recommendation for a flash tank would be a Flitton thermostatic style steam trap. You will have flash present, you'll have varying pressures present, you'll have varying loads present. What you're trying to accomplish on the flash tank is to get the condensate back to below saturated steam temperature, to a temperature you can pump it into your deaerator or your return tank, and then use that in the boiler. So highly recommended to use a Flitton thermostatic style trap.
Okay, excellent. Thank you. All right, so we seem to be out of time today. If you missed any part of today's presentation, we will post a recorded version on our website, which is industrialcontrolsonline.com. And within the next couple of days, we will email a link to the video and our contact information if you have any further questions or feedback for any future webinars. And also, like Jeff mentioned, we will be running another webinar on gaining energy efficiency via automated valves on December 1st. And I just wanted to thank everyone for attending, and we look forward to having you back soon.